The journey of high-grade cement begins deep within the earth, where raw limestone must be extracted with precision.
Massive blasts break the mountain into manageable boulders, the primary ingredient for the world's most vital construction material.
Specialized heavy machinery moves in immediately to collect the raw ore for the first stage of refinement.
Every load is measured by the ton, ensuring a constant flow of raw material to the crushing facility.
Here, the mountain is reduced to rubble as the primary crusher begins the process of transformation. Here, the mountain is reduced to rubble as the primary crusher begins the process of transformation. Under thousands of pounds of pressure, the raw limestone is shattered into a uniform size, ready for the long journey ahead. This belt is the factory's primary artery, pulsing with tons of material every hour.
Stretching for miles, this automated system eliminates the need for thousands of truck trips, reducing the plant's carbon footprint.
Upon arrival at the facility, the raw material is prepared for the most critical phase of its transformation. Thousands of tons are stored here, creating a buffer that keeps the kiln fed even when the quarry is silent. To maintain a consistent blend, the factory draws limestone from the base of the stockpile using massive automated reclaimers. To maintain a consistent blend, the factory draws limestone from the base of the stockpile using massive automated reclaimers.
The preheater tower stands as the heart of the facility, where gravity and heat begin their work.
Skilled technicians monitor the system's vitals from every level of the vertical process. Limestone alone isn't enough. Precise amounts of iron ore and clay are added to perfect the chemical recipe. Now, the raw ingredients enter the mill, where they will be ground into a powder finer than human hair. Before grinding begins, powerful magnets strip away any metallic impurities that could damage the sensitive internal machinery. Gigantic rollers exert hundreds of tons of force, beginning the reduction of raw stone into a fine, workable meal. Precision air classification ensures that only the particles meeting the exact micron-level specifications move forward. Continuous sampling is vital. The chemical balance must be perfect before the raw meal reaches the kiln. High-efficiency filters capture every grain of material, ensuring nothing is wasted and the environment is protected.
In the homogenizing silo, the mixture is blended into a perfectly consistent raw meal, ready for the extreme heat of the preheater tower.
Gravity pulls the raw meal down through a series of cyclones, where it is flash heated by recycled exhaust gases. In a split second, the calciner triggers a chemical reaction, stripping carbon dioxide from the limestone. Now, the material enters the rotary kiln, the most extreme environment in the entire factory. At a slight incline, the kiln's rotation forces the material to tumble slowly toward a wall of fire. Here, the raw meal undergoes a molecular change, fusing into a new substance, cement clinker.
In the sintering zone, the materials reach a near-liquid state, bonding into the dark, stony nodules known as clinker.
Rapid cooling is essential to lock in the chemical properties and prepare the material for the final grind. Any oversized clusters are mechanically shattered, ensuring a consistent feed for the storage silos. This volcanic-like rock is now the intermediate product, stable and ready for the final addition of gypsum. A precise percentage of gypsum is added to control the setting time of the final cement.
The final transformation occurs inside the ball mill, where the clinker is pulverized into the gray powder we know as cement.
Inside the mill, a violent storm of steel balls grinds the clinker into a powder so fine it feels like silk.
High-tech separators ensure that every grain of cement meets the exact particle size distribution required for structural strength.
From this nerve center, every motor, valve, and temperature sensor is monitored to maintain peak efficiency.
Automation extends to the lab, where X-ray technology provides a chemical breakdown of the cement every few minutes.
Using the power of compressed air, the finished product is pumped hundreds of feet into the air for final storage. These monolithic structures hold the finished cement, protected from moisture and ready for global distribution. Precision discharge systems draw the finished cement from the silos, ensuring a steady, metered flow to the final processing lines. High-speed rotary packers can fill thousands of bags per hour with surgical accuracy. Each bag is filled to within a fraction of a percent of its target weight, verified by instantaneous digital scales. Total quality management means every single unit is weighed to guarantee the customer gets exactly what they paid for. Automated cleaning and shaping prepare the bags for stable stacking, preventing damage during long-distance transport.
Precision robotics eliminate human fatigue, building perfect stacks that can withstand the rigors of the construction site. These prisms are the blueprints of strength, cast under controlled conditions to simulate real-world performance.
For 28 days, the samples cure in a simulated tropical environment to reach their maximum theoretical strength. Every bag must withstand thousands of pounds of pressure, meeting international standards for high-rise construction.
Laser technology confirms the fineness of the grind, ensuring the cement reacts perfectly when it finally meets water on the job site.
Only after passing every chemical and physical hurdle is the cement cleared for departure. Weatherproofing is the final layer of protection, shielding the reactive powder from atmospheric moisture.
In this climate-controlled environment, millions of tons of building potential wait for the call of the construction industry.
For large-scale infrastructure projects, the cement is dispatched in bulk, flowing directly into the veins of the city. Logistics networks coordinate hundreds of departures daily, feeding the hunger of a growing world.
And this is how modern factories produce cement from start to finish.
Subscribe for more real factory breakdowns.